This is video 1 of topic 11 on climate change. In this video, we'll talk about climate change and the Intergovernmental Panel on Climate Change, or IPCC. This is a quotation from the IPCC in 2013, which was their last major report. They wrote, "Warming of the climate system is unequivocal, and since the 1950s, many of the observed changes are unprecedented over decades to millennia. The atmosphere and ocean have warmed, the amounts of snow and ice have diminished, sea level has risen, and the concentrations of greenhouse gases have increased." They also explain, observations of the climate system are based on direct measurements and remote sensing from satellites and other platforms. Global scale observations from the instrumental era began in the mid-19th century for temperature and other variables, with more comprehensive and diverse sets of observations available for the period 1950 onwards. Paleoclimate reconstructions extend some records back hundreds to millions of years. Together, they provide a comprehensive view of the variability and long-term changes in the atmosphere, the ocean, the cryosphere, and the land surface. You'll notice as we go through these notes, there are a large number of acronyms. And so here are some of the important ones. IPCC is the Intergovernmental Panel on Climate Change. We'll be talking about AR5, which was the 5th assessment report released in 2013. WG1 is Working Group 1. You'll also hear about WG2 and WG3. And SPM is the summary for policymakers, which is about a 20 to 30 page document that is intended for policymakers and for members of the public who are interested. Here are some selected quotes from the IPCC AR5 WG1 SPM. They wrote, "Each of the last 3 decades has been successively warmer at the Earth's surface than any preceding decade since 1850. There's a figure that you'll see in a few minutes. In the Northern Hemisphere, 1983 to 2012 was likely the warmest 30-year period of the last 1400 years. And they say this with medium confidence. If you look at their documents, they define what they mean by likely and medium confidence. Okay, so here are some of the results. Here's the Northern Hemisphere spring snow cover, which is a slight decreasing trend. Here's the Arctic summer sea ice extent, likewise a downwards trend, and global average sea level change is an upwards trend, so sea levels are rising slowly. Human influence has been detected in warming of the atmosphere and the ocean, in changes in the global water cycle, in reductions in snow and ice, in global mean sea level rise, and in changes in some climate extremes. This evidence for human influence has grown since the last assessment report, AR4. It is extremely likely that human influence has been the dominant cause of the observed warming since the mid-20th century. Over the last 2 decades, the Greenland and Antarctic ice sheets have been losing mass, glaciers have continued to shrink almost worldwide, and Arctic sea ice and Northern Hemisphere spring snow cover have continued to decrease in extent. And finally, the rate of sea level rise since the mid-19th century has been larger than the mean rate during the previous 2 millennia. Over the period 1901 to 2010, global mean sea level rose by 0.19 meters. Another way we can assess climate change is by using complex simulation models of the entire world. And so these are results that are achieved with models using only natural forcings. So you can see here the blue envelope, okay, for all of these different quantities. And then the reddish or pinkish tone is for models using both natural and anthropogenic or human forcings. And you can see they trend upwards. And this black line is the set of observations. And so what you'll notice is that the observations match what we get from the models with anthropogenic forcings. If we leave out the anthropogenic forcings, we don't replicate the historical record. And notice there are different border colors for these various different graphs. The black bounded ones are the sea ice extent, the red are air temperature over land, and the blue ones are for oceanic heat content. There are, of course, uncertainties in our data. And so here's a quotation again from the IPCC. What I want to point out to you is, due to natural variability, trends based on short records are very sensitive to the beginning and end dates and do not in general reflect long-term climate trends. And so we do know that data uncertainties affect our results. That said, incomplete global coverage is a potential source of bias. And so this is an interesting study from about 7 years ago. Here you can see this is a reconstruction of the trend from 1980 to 2010. And depending on which type of reconstruction, you get slightly different results. They all do show temperature rising, but the amount of rise depends on how you process your data. So then what we're all interested in, of course, is how the climate will change into the future. And so this quotation again from IPCC says, global surface temperature for the end of the 21st century is likely to exceed 1.5 degrees Celsius relative to 1850 to 1900 for all RCP scenarios except the most mild. RCP stands for Representative Concentration Pathways. So it's the amount of climate forcing, the amount of energy added to the climate system. It is likely to exceed 2 degrees Celsius for the more serious climate change projections, RCP 6.0 and RCP 8.5, and more likely than not to exceed 2 degrees Celsius for our sort of moderate scenario, RCP 4.5. Warming will continue beyond 2100 under all RCP scenarios except the most mild. Warming will continue to exhibit interannual to decadal variability, so some degree of fluctuation and variability is natural, and will not be regionally uniform. Okay, and so here are the projections for the most extreme climate change. Here are the more moderate cases, and here's the most mild. And you'll see that even this one has 1 degree Celsius of change, and potentially as much as 1.5. Here are some projections from a number of different climate models. Okay, so here's the most mild climate change scenario, here's the most extreme, and here are changes in average precipitation. So rainfall for these two, temperature for these two, and they're comparing the historical record 1986 to 2005 against 2081 to 2100. A few important notes. RCP means representative concentration pathway, and so the number RCP 2.6 or 8.5 is the climate forcing in watts per square meter. And here's the number of models that were used to produce these results. Here's another example of how the climate may change. And then here's a set of values that you can look up later on showing potential variations of global mean surface temperature and global mean sea level rise. Here are these scenarios from most mild to most severe, mean temperature rise, and again mean temperature rise, as well as the likely range. Going back about 30 years, people have been talking about how greater than 2 degrees Celsius is dangerous climate change. We may reach that point in 30 years from 2013. And a more recent piece in the Washington Post explains this in a bit more detail and why 2 degrees Celsius is deemed dangerous. So I encourage you to look that up as well. The previous results were for larger scale change. These now are what we might experience more locally. This is from a study by Mora and co-workers from 2013 published in Nature. If you would like to look it up, here's the URL so that you can get it from the Nature journal. Here's what we might expect to see in Edmonton based on, note, only one model. And so these are not predictions, these are possibilities. Okay, so here's the historical record for climate variation. And so you see that our average temperature is somewhere above 2 degrees Celsius. Under the most extreme case of RCP 8.5, you can see that our temperature trends up pretty significantly. Under a much more moderate case, sort of a medium case of RCP 4.5, we're looking at this type of variation, again from just one model. And what it shows is, notice there's this envelope here of sort of gray shading. What it's showing is what the natural range of variability was historically. And you can see this red line for the minimum to the maximum is completely outside that envelope by this point. So about 2064, I believe. And then it just trends upwards. And so we're outside the natural range of variability that we've seen in this area by about 2065-ish. Okay, in other places though, it comes earlier. So here's 2050, in Miami, significantly earlier, and you'll notice in the tropical regions, they're outside their historical natural variability bounds by 2033, 2031, and so climate change is occurring now. Here's a summary table. I won't go through it here, but note that these are some of the climate change consequences on various different important parameters of the climate. Okay, so take a look at this table as well. Now here is our increasing certainty about climate change. These are quotations from historical IPCC reports. The first one was issued in 1990, and they said, "The observed increase in temperatures could be largely due to natural variability. Alternatively, this variability and other man-made factors could have offset a still larger man-made greenhouse warming." It's not exactly gender-neutral wording either. Okay, so could be largely due to natural variability, but man-made or human-made factors could also have some effect 30 years ago. The balance of evidence in 1995 suggests a discernible human influence on global climate. Then in 2001, there is new and stronger evidence that most of the warming observed over the last 50 years is attributable to human activities. Then in 2007, most of the observed increase in globally average temperatures since the mid-20th century is very likely due to the observed increase in anthropogenic greenhouse gas concentrations. And then finally, the most recent report, which is now 7 years old, said human influence on the climate system is clear. So you may be asking now, who or what is the IPCC? The IPCC is the Intergovernmental Panel on Climate Change. It was established in 1988 by the World Meteorological Organization and the United Nations Environment Programme to, first of all, assess available scientific information on climate change. Second, assess environmental and socioeconomic effects of climate change. And third, formulate appropriate response strategies. The IPCC provided technical documentation that led to the United Nations Framework Convention on Climate Change, also called the UNFCCC, signed by 150 nations at the UN Conference on Environment and Development, which was called also the Earth Summit that you may have heard about, held in Rio de Janeiro back in 1992. Another interesting thing that happened at this Earth Summit was the proposal of Agenda 21, which talks about the precautionary principle that we don't tend to apply. And so it says, "The precautionary approach shall be widely applied by states, nations here, according to their capabilities. Where there are threats of serious or irreversible damage, lack of full scientific certainty shall not be used as a reason for postponing cost-effective measures to prevent environmental degradation." Note that the UNFCCC is a climate treaty. It laid the groundwork for nations to stabilize greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous interference with the climate system. It came into force on March 21st, 1994, after 50 countries had ratified the treaty, and you may have heard of the Kyoto Protocol. That began in 1997 with the UNFCCC. It's important to note that the IPCC does not carry out research itself. Instead, it relies on thousands of independent climate and policy experts from nations from around the world. Experts contribute as authors and reviewers, and they use the published academic literature, government reports, and data that are available to them. The principal output of the IPCC is a set of authoritative technical reports The first was called the First Assessment Report, Second Assessment Report, Third Assessment Report, and then they realized that they would have trouble with these acronyms for the fourth and so on, so they went to AR4, AR5. The next assessment reports are due fairly soon. They'll be AR6, Working Group 1, 2, and 3, will be released in 2021, with the synthesis report released in June of 2022. The reports from these three working groups are very dense. They're often very interesting reading, but they can be hundreds of pages long, whereas the synthesis report will be typically 30 pages. If you're interested in accessing these reports, you can get them from ipcc.ch. This is for Switzerland. There are three focus areas, WG1, 2, and 3, which are for science, impacts and adaptation, and mitigation. Here's a quote from IPCC. It says, according to IPCC procedures, the synthesis reports should synthesize and integrate materials contained within the assessment reports and special reports, and should be written in a non-technical style suitable for policymakers and address a broad range of policy-relevant but policy-neutral questions approved by the panel. They're composed of two sections, a summary for policymakers, SPM, of 5 to 10 pages, and a longer report of 30 to 50 pages. The writing of AR6 SYR will be based on the content of the three working groups' assessment reports and the three special reports that were released recently. And of course, the working groups are connected. So the mitigation group develops scenarios of possible combinations of population, economic growth, and technology drivers to produce emissions scenarios. Emission scenarios are those RCPs, and they're converted by climate models into regional temperatures and climate impacts. And then impacts can inform decision makers about the potential to mitigate effects, reduce the driving forces like emissions, or adapt to changes, so things like raising levees along the sides of rivers. Okay, and you can take a look at this figure here to see a little bit more about how these things are connected. This ends video 1.